Welcome to Rust tutorial number 10. In this video, you will learn generics, which let you write code that works with many types without repeating yourself. You already use generics every day in Rust. Vec T, option T, and result T, E are all generic types. The T is a placeholder for any type. Without generics, you would write separate functions for each type. One function for integers, another for floats, another for strings. That is 3 functions doing the same thing. With generics, you write one function using a type parameter t, and it works with any type that meets the trait bounds. A generic function uses angle bracket t after the function name. The trait bound like partial OR means t can be any type that supports comparison. Now this single function works with numbers, strings, and any type that implements the required trait. You call it like any normal function. Generic functions can have multiple trait bounds. Default plus clone means the type must have a default value and must be clonable. These bounds tell the compiler exactly what operations you can perform on the generic type. Without bounds, you can only move and drop generic values. Structs can also be generic. A pair struct with type parameter t has 2 fields, both of the same type. You can create pairs of integers, pairs of strings, or pairs of any type. The generic parameter ensures both fields have the same type, which the compiler enforces at compile time. You write methods for generic structs with impl angle bracket t. The new method creates a pair, and swap returns a new pair with the fields reversed. These methods work for any type t. Notice that no trait bounds are needed here because we only move values around. Conditional methods only exist when t meets certain trait bounds. You add bounds to the impl block. For example, the larger method only exists when t implements display and partial OR. If you try to call larger on a pair of vectors, the compiler rejects it because vec does not implement display. You can use multiple generic type parameters separated by commas. A key value struct with k and v parameters lets the key and value be different types. You can have a string key with an integer value or any other combination. Each parameter can have its own trait bounds. Enums can also be generic. Option and result from the standard library are generic enums. You can create your own. A container enum might have empty, single with one value, and multiple with a vector. Methods on generic enums use match to handle each variant, just like regular enums. Trait bounds tell the compiler what a generic type can do. A single bound requires one trait. Multiple bounds use plus to require several traits. When bounds get complex with many parameters, use a where clause for readability. The where clause does the same thing, but keeps the function signature clean. Let us build a complete generic data structure, a stack. It wraps a vec and provides push, pop, peek, is empty, and size methods. Notice that stack does not require any trait bounds on t. The methods only use vec operations, which work with any type. You add bounds only when needed. This generic stack works with any type. You can create a stack of integers, a stack of strings, or a stack of any custom type. Each version is type safe. You cannot push a string onto an integer stack. The compiler generates specific code for each type you actually use. How does Rust make generics fast? Through monomorphization. At compile time, Rust looks at every place you use a generic type and creates a specific version for that type. When you use pair with integers and pair with strings, the compiler generates 2 separate struct definitions. Monomorphization means generics have 0 runtime cost. They are as fast as writing specific types by hand. The trade-off is a larger binary because the compiler creates more code, and all type errors are caught at compile time. This is different from Java or Python, where generics use type erasure or duck typing. Sometimes the compiler cannot figure out the generic type. You specify it with the turbofish syntax, which is a double colon followed by the type in angle brackets. For example, collect needs to know what type to collect into. You write collect : vec. The name turbofish comes from the syntax looking like a fish. A common mistake is forgetting trait bounds. If you try to print a generic T without requiring display, the compiler rejects it. Another mistake is using too many bounds when a concrete type would be simpler. And be careful returning references from generic functions. Usually you should return own values. The impl trait syntax is sugar for generics in argument position. Writing item : impl display is the same as using a generic with a display bound. But in return position, impl trait hides the concrete type from the caller. The function chooses the type, and the caller only sees the trait. You already use generics everywhere in Rust. Vec_t is generic over element type. Hashmap kv is generic over key and value types. Option T and result TE are generic enums. Understanding generics helps you read the standard library documentation and write flexible, reusable code. Let us review what we covered. Generic functions use T in angle brackets. Generic structs and enums use type parameters. Trait bounds restrict what T can be, where clauses improve readability. Monomorphization makes generics zero cost. The turbofish syntax specifies types explicitly, and conditional methods appear only when bounds are met. In the next tutorial, we learn lifetimes, which tell Rust how long references are valid. Lifetimes are the final piece of Rust's ownership system. They might seem difficult at first, but once you understand them, the borrow checker becomes your friend. See you in the next video.